Electrical engineering work is indeed being performed overseas for United States projects. Many companies have discovered that hiring electrical engineers from overseas is a more cost-effective option. However, this approach isn't without its potential drawbacks. There can be challenges related to communication and ensuring a thorough understanding of United States codes and standards. A significant number of foreign-born electrical engineers have been emigrating to the United States in recent years. This influx is partly driven by the robust demand for electrical engineers within the United States, coupled with the relatively attractive salaries offered in the profession. Electrical engineering salaries are generally not stagnating in the same way as those of wiremen or installers. In fact, data suggests that electrical engineering salaries have been on an upward trajectory in recent years. To provide a concrete example, according to the Bureau of Labor Statistics, the median annual salary for electrical engineers in May 2004 was approximately $59,210. This figure represents a 3.2% increase compared to the previous year. It's important to consider the factors that contribute to job security and career success in the current economic landscape. If you possess a trade or skill that is difficult to replace or highly specialized, you are likely to fare well, even with shifts in the manufacturing base moving out of the country. Conversely, individuals with limited training, low skill sets, or easily replaceable skills may encounter more challenges adapting to these changes in the economy. Considering further information, we can look at potential areas of specialization within electrical engineering. Firstly, there's power systems engineering, which deals with the generation, transmission, and distribution of electrical power. This area is always in demand, especially with the growing emphasis on renewable energy sources and smart grids. Secondly, you could consider control systems engineering, which focuses on designing and implementing systems that control the behavior of other devices or systems. This is crucial in industries like manufacturing, robotics, and aerospace. Thirdly, electronics and microelectronics is a field that involves designing and developing electronic circuits and devices, often at the microscopic level. This area is constantly evolving with advancements in technology. Fourthly, signal processing is a vital specialization that deals with analyzing and manipulating signals such as audio, video, and data. It's essential in communications, medical imaging, and many other fields. Fifthly, telecommunications engineering focuses on the design and implementation of communication systems, including wireless networks, fiber optics, and satellite communication. The demand for skilled professionals in this area continues to grow, with the increasing reliance on digital communication. In addition to these core areas, there are emerging fields such as artificial intelligence and machine learning, which are increasingly integrated into electrical engineering applications. Understanding these areas and choosing a specialization that aligns with your interests and aptitudes can greatly enhance your career prospects. Thinking about education, it is vital to choose a program that is accredited by a BET, which ensures that the curriculum meets industry standards and prepares you for professional practice. Consider pursuing advanced degrees such as a master's or doctorate to deepen your knowledge and expertise in a specialized area. Furthermore, gaining practical experience through internships, co-op programs, or research opportunities is highly recommended. This allows you to apply your theoretical knowledge to real-world problems and develop valuable skills. Let's discuss the importance of staying current with industry trends and technological advancements. The field of electrical engineering is constantly evolving, so it's crucial to engage in continuous learning throughout your career. This can involve attending conferences, workshops, and seminars, reading industry publications, and participating in online courses or professional development programs. Furthermore, obtaining professional certifications such as the Professional Engineer or P.E. license can enhance your credibility and career opportunities. To get a better idea of current salary trends, you can consult various resources such as the Bureau of Labor Statistics, salary surveys conducted by professional organizations like the Institute of Electrical and Electronics Engineers, or IEE, and online salary databases like Glassdoor or Salary.com. It's important to note that salary levels can vary depending on factors such as location, experience, education, and specialization. Another factor that helps salaries is by staying up to date with technology. You can do this by constantly reading magazines, research papers, or even getting additional education. Don't be complacent and think that you know everything. As technologies rapidly change, there is always something to learn. Let's consider the impact of automation and artificial intelligence on the electrical engineering profession. While some tasks may be automated, these technologies also create new opportunities for electrical engineers to design, develop, and maintain these systems. Electrical engineers who are proficient in areas such as machine learning, robotics, and data analytics will be well positioned to thrive in this evolving landscape. You can also consider the role of electrical engineers in addressing global challenges such as climate change and sustainable development. Electrical engineers are essential in developing renewable energy technologies, improving energy efficiency, and designing smart grids that can integrate distributed energy resources. Also consider the evolving needs of power and its distribution. As time goes on, the population is going to be expanding as well, and therefore cities will need to adjust and expand the existing infrastructure to handle the increasing demand. Thinking about entrepreneurial opportunities, electrical engineers can start their own consulting firms or develop innovative products and solutions. With the increasing demand for specialized expertise, independent consultants can provide valuable services to companies in areas such as power systems analysis, control systems design, and embedded systems development. This is very specialized since you will have to know a lot to be able to be your own boss. You also have to understand business processes. Also consider the ethical considerations in electrical engineering practice. Electrical engineers have a responsibility to ensure that their designs are safe, reliable, and environmentally responsible. They must also adhere to professional codes of ethics and act with integrity and honesty in their work. These are very important as you are in a position of power and authority. Finally, let's discuss the importance of networking and building relationships with other professionals in the field. Attending industry events, joining professional organizations, and participating in online communities can help you connect with other engineers, learn about new opportunities, and advance your career. Don't be afraid to put yourself out there and connect with people. Now let's delve into the specific skills and knowledge that are highly valued in the electrical engineering profession. Firstly, a strong foundation in mathematics and physics is essential. Electrical engineering relies heavily on mathematical concepts such as calculus, differential equations, linear algebra, and complex analysis. A solid understanding of physics, particularly electromagnetism, circuit theory, and semiconductor physics, is also crucial. Secondly, proficiency in circuit analysis and design is a fundamental skill for electrical engineers. This includes the ability to analyze both analog and digital circuits, design electronic circuits to meet specific requirements, and use simulation software to verify circuit performance. Thirdly, expertise in embedded systems design is increasingly important. Embedded systems are computer systems that are integrated into other devices or systems, such as automobiles, appliances, and industrial equipment. Electrical engineers who can design and program embedded systems are in high demand. Fourthly, knowledge of power systems engineering is essential for those working in the power industry. This includes understanding the principles of power generation, transmission, and distribution, as well as the design and operation of power system components such as transformers, generators, and transmission lines. Fifthly, familiarity with control systems engineering is crucial for designing and implementing systems that control the behavior of other devices or systems. This involves understanding control theory, feedback control systems, and the use of sensors and actuators. Another important skill is proficiency in programming languages such as C, C++, and Python. These languages are widely used in electrical engineering for tasks such as embedded systems programming, data analysis, and simulation. Familiarity with hardware description languages such as VHDL and Verilog is also valuable for designing digital circuits and systems. In addition to these technical skills, certain soft skills are also highly valued in the electrical engineering profession. These include problem-solving skills, critical thinking skills, communication skills, teamwork skills, and leadership skills. Electrical engineers often work in teams, so the ability to collaborate effectively with others is essential. Let's further expand on the importance of understanding and adhering to relevant codes and standards. In the United States, the National Electrical Code, or NEC, also known as NFPA 70, is the primary standard for safe electrical installations. Electrical engineers must be familiar with the NEC and other applicable codes and standards to ensure that their designs comply with safety regulations. Examples include understanding requirements for grounding, overcurrent protection, wiring methods, and equipment installation. Furthermore, familiarity with industry-specific standards such as those developed by the IEEE or the American National Standards Institute or ANSI is also important. These standards provide guidelines for the design, testing, and performance of electrical equipment and systems. Also, let's discuss some of the emerging trends and technologies that are shaping the future of electrical engineering. One such trend is the increasing use of artificial intelligence and machine learning in electrical engineering applications. For example, AI and machine learning are being used to develop smart grids that can optimize energy distribution, predict equipment failures, and improve grid reliability. AI and machine learning are also being used in areas such as image processing, signal processing, and control systems. Another important trend is the growth of the Internet of Things, or IoT, which involves connecting devices and systems to the Internet. Electrical engineers play a crucial role in designing and developing IoT devices, as well as the communication networks and data analytics systems that support them. Also, electrical engineers are essential for the development of renewable energy technologies such as solar power, wind power, and energy storage systems. As the world transitions to a more sustainable energy future, the demand for skilled professionals in these areas will continue to grow. Nanotechnology, which involves manipulating materials at the atomic and molecular level, is also impacting electrical engineering. Nanomaterials are being used to develop new electronic devices with improved performance, reduced size, and lower power consumption. We can also look at how electrical engineers are developing advanced medical devices such as MRI scanners, X-ray machines, and diagnostic tools. These devices rely on sophisticated electrical and electronic systems, and electrical engineers play a critical role in their design and development. Let's consider the impact of government regulations and policies in the electrical engineering profession. Government regulations can influence the types of projects that electrical engineers work on, as well as the standards and codes that they must follow. For example, government policies that promote renewable energy can create opportunities for electrical engineers working in that field. Additionally, government funding for research and development can support innovation and advancement in electrical engineering technologies. Staying informed about government regulations and policies is therefore important for electrical engineers. With that being said, let's talk more about the importance of lifelong learning and professional development. Electrical engineering is a rapidly changing field, so it's crucial to engage in continuous learning throughout your career. This can involve attending conferences, workshops, and seminars, reading industry publications, and participating in online courses or professional development programs. Let's revisit the importance of networking and building relationships with other professionals in the field. Networking can help you learn about new job opportunities, share ideas, and advance your career.